So hello everyone, in this video we'll solve another LeetCode problem, that is surrounded regions. Now before that, this is my 100th video on this channel. So this is the second time I am recording this video because the first time I recorded that was 32 minutes long and I just forgot to connect the mic, so it all went in vain. So yeah, anyways, let us record it for the second time. First time for you, but yeah, second time for me. So anyways, let us start with the problem. So this is the LeetCode problem 130 that is named as surrounded regions. So let us read the problem statement first. Now before that, this is medium category and you can just mark this question as important because it involves the concept of DFS, which is a traversal technique. Full form is like depth first search, obviously if you have solved DFS problems. So yeah, anyways, this is the important problem because the concept that is used here is used in many of the harder problems as well. So yeah, it is an important problem marked as medium on LeetCode. So let us read the problem statement first. So you are given m cross n matrix board containing letters x and 0 and capture regions that are surrounded. Now then they have given these 3 bullet points which defines connect, region and surround. Now we will understand this question in our terms in easy way, but for the simplicity or sake of understanding or reading the problem, just read it first. Connect. A cell is connected to adjacent cells horizontally or vertically. Region. To form a region, connect every 0 cell. Surround. The region is surrounded with X cells if you can connect the region with X cells and none of the regions are on the edge of the board. Then they have given the additional line, that is to capture a surrounded region, replace all zeros with X, and you need to do this in place. Now this is one also important thing. What does that mean? This simply means that you don't need to connect, you don't need to create another 2D matrix and return that. You just need to make changes in this only, because this is a void function, so it will automatically take the original array with the replaced ones. So this is what the question is saying. So when I first read this problem, I did not understand what this question is trying to say. Now let me just clarify it to you or simplify it for you what this question is saying. Now let us understand this problem with the help of this first example, because this is how you will understand this question in more simple terms. So let us go through this first example first. So let me just take this down. Yeah, so this is the first example. They have given the input board which looks something like this. Now what the question is saying, that you need to replace all the zeros to X. Obviously they have provided the m cross n grid that is named as board, that obviously you have all understood, but the main part is that you need to convert all the zeros to X based on the condition that those connected zeros, now these zeros can be connected either horizontally or vertically. All these connected zeros should be surrounded by X in all the 4 directions: up direction, right direction, down direction and left direction. So in this question you can also see that this 0, so let me just change the color of the pen. So this 0 and this 0, these 3 are connected either horizontally or vertically. This is not connected because this is diagonal to this 0. Now these 3 zeros are connected to each other either horizontally or vertically. Now we can replace these zeros with X because these 3 zeros are surrounded by X in all the directions. You can see that this is X here, this is X here, this is X here, this is also this and this. This makes no sense, this only. Yeah, so in all the 4 directions, that is upwards also, rightwards also, down for this 0, left for this 0 and down for this particular 0 and left for this particular 0. So these all are surrounded by X only. So these zeros can be converted to X, none other zeros can be converted to X. Now why this is not why this particular 0 remained as it is? Because this is surrounded with x also, but not in all the direction, because you can see this is on the border or edge of the board, so there will no x present in the downward direction, so this remained as it is. So this is simply what the question is saying. Now how will we solve this problem, or what algorithm we need to follow in order to solve this problem? Let us understand that first, then we will dry run on one simple example to understand the algorithm in more better way. So let us understand the algorithm first. Now algorithm is very simple. If you have observed one particular thing, so there is one particular observation and the most important observation in this question that will help us getting the algorithm. What is that particular observation? That one particular observation is that all the zeros that are on the edge of the board can never be converted to x, because there will be one direction by which they are not surrounded by x. What is that? What does that means? Now that particular zero can obviously not be converted to x. Also, all the zeros that are connected to it will also not be converted to x, because they are connected to this particular boundary zeros either horizontally or vertically. We will understand in more detail with the help of one example in which we will dry run, but how our algorithm will work, let us understand that first. So based on that particular condition, what we can say, we need to find first all the boundary zeros. So where will we find the boundary zeros? We will have four directions: in first row, last row, first column and last column. So these are the four boundaries. So find boundary 0. What is the second thing? After finding the boundary zeros, we need to find all the zeros that are connected to it either horizontally or vertically. That means in all the four directions: up, right, left and down. Now how we will do that? We will apply DFS, because DFS is great for doing such things. So we will apply DFS to find all the adjacent zeros. Now after finding all the adjacent zeros that are connected to the boundary cell, what we need to do? Now we are sure for one thing that all the zeros that are on the boundary and that are connected to that boundary zero will not be converted to x. Now that surely means that all the remaining zeros will be converted to x, because they are not connected by any of the boundary zeros, and also they are not on the boundary. So obviously they will be surrounded by x in all the directions. So that simply means that what we will do, we will make one visited vector or visited matrix which will make sure what are the boundary zeros and connected to it. We will mark them as 1. All the remaining ones are the valid zeros to be replaced by x. This is the simple algorithm. Now if you didn't understand this part, don't worry, we will take one very simple example that will clear all your doubts, and dry run on this particular example will help you understand this problem in more better way. So let us dry run first. So this is the example which I have taken by myself. This is not present in the test case of the LeetCode, but yeah, this will help us understand the question and algorithm in more better way. So let us start with the dry run now. Now what we need to do, we need to iterate on all the four boundaries. So first we will start with the first row. So we will find the boundary zeros. So this is x, we do nothing. So again we go to next cell. This is x also, we do nothing. Again this is x, we do nothing. We got x, we do nothing. Now we got 0. That means this 0 will surely not be converted to x. So we will mark this as 1 in our visited matrix. This one represents that there is one 0 at this position that is on the boundary or connected to some other 0 which is on the boundary, which will not be converted to x. This simply means this. Now we found this particular 0. What was the second step? Second step was to find the adjacent zeros connected to it. How will we do? We will do DFS. We will search in the upward direction. so there is nothing because this is on the edge of the grid. We will check left. Left is x, so we do nothing. Downwards is again x, so we do nothing. Rightwards we found a 0. Now these two zeros are connected, so again that means that this 0 will also not be converted to x. Now if this will not be converted to x, we need to mark this as 1 in our visited matrix. Now again what we need to do, for this particular 0 we need to apply DFS to find some connected 0. In the up direction we do nothing, right direction we do nothing, down direction is x, so we do nothing, left direction we found a 0 but that is already visited, so we do nothing. So we have completed the iteration on the first row. Now let us iterate on the first column, that is this one. So if we iterate on this first column, we found x here, so we do nothing. Again we go down, we got x, so we do nothing. Again x, we do nothing. Now we got one 0. Now this is the 0 which is on the boundary, so again we need to mark this as 1 in our visited matrix. So yeah, now what was the second step? Second step was to find the adjacent zeros that are connected to this particular 0. So we apply DFS. Up direction is x, so we do nothing. Left direction is nothing, so we do nothing. Downward direction, yes, we got another 0. Now we got another 0, that means this particular 0 will also not be replaced to x. So we will mark this in our visited matrix to 1. Now we will continue our DFS traversal. We have gone down, now we go to right. We found again one 0. Now this is also a 0 which is connected, so we need to mark this also 1 in our visited matrix, because this will also not be converted to x, because this is connected to boundary 0. Now what we need to do, we need to continue the DFS traversal for this particular 0. So downwards nothing, rightwards there is x, so we do nothing. Upwards there is one 0 but that is already visited, so we do nothing. In the left direction we do nothing because this is on the boundary. Now what is the next step? Next step is to DFS traversal for this particular 0. In the upward direction we have x, so we do nothing. Left direction we have 0 which is already visited, so we do nothing. In the downward direction we have x, so we do nothing. In the rightwards we again find one 0. We again find one 0 which is either horizontally or vertically connected. That means this particular 0 will also not be replaced to x. That means that we need to mark this 1 in our visited matrix. Now what we need to do, for this particular 0 we will apply DFS again. DFS, so up direction x, so we do nothing. Left direction 0 but already visited, so we do nothing. Downward direction again x, so we do nothing. Right direction again find one 0. Now we again find one 0 which is either connected horizontally or vertically, so that means this will also not be converted to x. Now if this is not converted to x, we need to mark this 1 in our visited matrix for this particular 0. Now what we need to do, we need to continue our DFS traversal for this particular 0. Now in the up direction we have x, so we do nothing. Right direction already visited 0, so we do nothing. In the down direction we also have x, so we do nothing. In the right direction also we have x, so we do nothing. Now we have done for the first row traversal, first column traversal. Now it's time for the last row and last column. So let us start with the last row traversal first. So we found one 0 but we can't do anything because that is already visited, that we have already seen before, so we do nothing. Then we have x, 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 x and x. So no zeros in the last row except this one which was already done by us. So we have also completed the iteration on the last row. Now only remaining is the last column. So last column, if we start, we have this 0 which is already visited, so we don't need to take care about that. We have already made the DFS traversal. Then we have all the x, so no zeros in the last column except for this one, so we have completed the iteration for the last column as well. Now what is the next step? How will we identify what all zeros we need to convert to x? So let us see that now. I'll just clear all these things so that we can understand it in more better way. So let me just clear all these things. Now what we need to do, we need to convert all the zeros to x which are surrounded by x in all the directions. So how will we do it? We have already neglected those zeros which are not possible to convert to x. Now obviously all the remaining zeros will now be converted to x because they will surely be surrounded by x. So let us traverse each and every cell one by one. Wherever we get 0 which is not 1 in this visited matrix, that will be converted to x. So let us traverse one by one. So this is x, so we do nothing, do nothing, do nothing, do nothing. We got 1 0. So can we convert it to x? Let us see in the visited matrix. So with this visited matrix says 1. 1 means you cannot convert to x. So that means we do nothing here. We again find 1 0, but this is again 1 in the visited matrix, so we do nothing. So we traverse to the next cell which is x, so we do nothing. Now we got 1 0. So can we convert it to x? Let us ask the visited matrix. So visited matrix says 0. 0 means yes, we can convert this particular 0 to x. So we will now convert this 0 to x. Let us traverse further. So we again found 1 0. Can we convert it to x? What does the visited matrix say? Visited matrix say yes, you can convert it. So we will convert this 0 to x. Now we'll again traverse further. This is x, this is x, this is x. Now this entire column is again x. So this entire row is x. So we don't need to take care about that. Now we again found 1 0, but this is 1, so we do nothing. Again found 1 0, but 1 in the visited, so we do nothing. Again for these two zeros we have 1 marked in the visited matrix, so we do nothing. Rest is x. Now we again found 1 0, but this is 1 in the visited matrix, so we do nothing. Rest all are x. So what our final matrix would look like, just redraw it. So the first row would look something like this, 4x and 2 zeros. This second row would look like this, x, 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 like all the elements here are x only. The third row also all the elements are, or all the cells are filled with x only. Now for the fourth row, 4 zeros and 2x, and for the last row, my bad, this one will be 0 and all the remaining one will be 5x. So this is what our final matrix would look like. Now I hope you understand this dry run part. I have tried my best to make you all understand this particular question. So I hope you understand the algorithm part and this dry run part as well. So let us directly jump onto the code now. Let us see how we will write the code now. So let us see the code. So this is the code. So let us see the code step by step. Now this code is exactly same how I have dry run that particular example. Nothing is changed. So this is exactly same I have implemented what I have explained so far. So let us go step by step. So first I have declared these two variables n and m. This is the size of the matrix n cross m. So in the question it is said m cross n, but I generally take n cross m. This is like just the convention. I have just changed the variable names. That doesn't make any difference. This is the only change in this code. Rest all thing is same. Yeah. Then I have declared two arrays, dr and dc. Now if you have solved DFS problems, you know what these two arrays are. So these two arrays are the direction arrays, which help us in traversing in the up direction, right direction, down direction, and the left direction. So these are nothing, just the coordinate like 1, 0, 0, -1. So if you look, this is 1, 0, 0, -1, -1, 0, and 0, 1. So this will help us in traversing the up, right, down, and left, left direction. Then I have declared the visited matrix, which is initialized to all zeros. Then I have done the traversal part. Now we'll be traversing what we have seen in the first step. We need to traverse the diagonals, not the diagonals, the boundaries. So there will be 4 boundaries, two rows, first row, last row, and two columns, first column and the last column. So this one is for the first row and last row. So 0 comma I is for the first row, n minus 1 comma I is for the last row. So what we are doing, we are just like whenever we got a 0, we just need to find if there are any connected zeros either horizontally or vertically. So we are just running a DFS to find if there is any 0 connected to it. Just that, just what we have seen in the explanation part, nothing else. Then we are checking for the first column and the last column. So I comma 0 is for the first column, I comma m minus 1 is for the last column. Again same, if we found any 0, we do a DFS to find some other connected zeros. And in the end, what we are doing, we are just checking if this is for the conversion part. All the zeros which are not on the boundary and connected to the boundary 0, we need to replace it with x. So we are finding if there is any 0 and which is marked 0 in the visited matrix, that is which is 0 in the board as well as its visited part is also 0. That means this particular 0 is ready to convert it to x. So we are finding those zeros. So this is the same, not visited of I comma j is this only, it is value 0, and board of I comma 0 is simply if we found any zeroth cell, like cell with 0. Now if this is the case, that means we need to replace this particular board of I comma j with x. So this is what we have done, and this is the simple DFS, nothing advanced in this. We are just checking in all the 4 directions, up, right, down and left. This is self-explanatory. So yeah, this was about the code. So I have tried my best to explain this question in most easy way. So I hope you understand the algorithm, the dry run part and the code as well. So I hope you enjoyed this video. Thank you.